All right, our last new topic for chapter 2, we're going to learn about the quadratic formula. So remember in the last example when we were doing the completing the square, so like this one right here, we were completing the square because it helped us more easily find the vertex when it's in vertex form. Well, now you're going to get the cheat, the easy way to be able to find the roots, right, of a quadratic formula without having to put it into vertex form. So the quadratic formula is this: x equals negative b plus or minus the root of this whole thing, b squared minus 4ac, that's called the discriminant, over 2a. A cannot be 0, right? We're talking about these for a, b, and c. So a cannot be 0 because if this was a 0, it would not be a square anymore. It would be just a linear function. And then the second thing is all they've done here is solve for x. This gives you all the solutions for x when y equals 0. So they've set this equal to 0 and rearranged it to solve for x. And then you can use this every time to be able to essentially find the zeros of the function, right? Plugging in the different coefficients. So let's do an example. 3x squared minus 4x minus 9 equals 0. Solve for x. Now instead of rearranging and doing everything, I can just use the quadratic formula. X equals negative b, so negative of negative 4, plus or minus the square root of b squared. Well, b is negative 4, b squared is 16, minus 4 times a is 3 times c is negative 9, all over 2 times a, which is 3. Okay, now I'm just doing arithmetic to figure this out. So now x equals 4 plus or minus the square root of 16 minus 4 times 3 is 12. 12 times negative 9 is negative 108, so this becomes plus 108 all over 6. All right, so then this becomes 4 plus or minus the square root of 124 over 6. Okay, so now here's that thing where I can simplify, right? I'm seeing that there's a 4 and a 6, and if I can get a 2 from under the square root, I can simplify. So now I'm going to say this is the same as 4. I'm going to write over here so I have more space. This is the same as 4 plus or minus. Okay, if I want to pull a 2 out, I'm trying to see if I can do 4 times some number to give me 124. And I did this on my calculator just checking, and it ends up being 4 times 31 is 24, but you guys get 124. You can see that 4 times 30 is 120, plus 4 more, all over 6. Now that's helpful because I can take this 4 out of the square root. It becomes 4 plus or minus the square root of 4 is 2, and we still have the square root of 31 left there, all over 6. Now I can simplify, right? Get another color here. Take that 2 out, this becomes 2, this becomes 3. Just divided them all by 2. So now I have 2 plus or minus root 31 over 3. So my two solutions for when y is 0 is that x can equal 2 plus the root 31 over 3, or x can equal 2 minus root 31 over 3, right? And so what you're thinking is if that's the parabola, if I evaluate that and get a number, that's where the parabola is crossing the x-axis, right? One of those would be 2 plus root 31, so this one, and then this other one would be x equals 2 minus root 31. I don't know if they're positive or negative. I'd have to solve them, but it's basically giving you these 2 points where it crosses the x-axis, okay? All right, so now let's try another one. X squared minus 9x plus 27. Okay, so one thing to note is that usually you use the quadratic formula when you can't factor, right? Because if you could factor this, it would be really easy to find the zeros. But I start thinking a times b is there, if a times b has to give me 27 and a plus b has to give me 9. That's 9 and 3, right? This is going to be negative 9. You start to notice that it's not going to work out. So because it's not going to work out, I'm just going to use the quadratic, right? Sometimes if it's easily factored, I've seen kids waste a lot of time doing the quadratic when they could have just factored it. So it's negative b so negative of negative 9, plus or minus the square root of b squared, so that's negative 9 squared, that's 81, minus 4 times a is 1 times c is 27, all over 2 times a is just 1. Okay, now we're just at the simplifying phase. So this comes out to be positive 9, right? Plus or minus 81 minus, all of that becomes 4 times 1 is 27 is 108, all over 2, which then that equals 9 plus or minus 81 minus 108 becomes negative 27, all over 2. And now I'm seeing that I can, if I'm looking at 27, I know that 27 is equal to 9 times negative 3. Okay, and that's helpful because I can find the square root of 9. That is 9 plus or minus 3 times the square root of negative 3, all over 2. Okay, and now I can see that that can break up into 9 plus or minus 3 times the square root of negative 1 times 3, all over 2. And that's helpful because I know the value of the square root of negative 1 is I, so I can take that out. All times root 3, all over 2. Right? So my two solutions here is x can be equal to 9 plus 3i times root 3 over 2, and then my second solution is 9 minus 3i times root 3 over 2. All right, what about this one? 6x squared minus 7x minus 20 equals 0. So I'm already thinking that there's no factors of 20 that are going to give me 7. 4 and 5, 10 and 2. So I'm going to use the quadratic. Plus there's a 6 here. I mean, maybe, right? With that 6 there, now it works. At first I was just ignoring it. So I could start thinking about, what could this be? I know one could be a 2x and one could be a 3x. And then maybe we could do plus 4 minus 5. Does that work? That's 6x squared minus 10x plus 12x minus 20. Those work, but this isn't giving me 7. It's giving me 2. I need negative 7. What if I switched it? What if I did 2x minus 5 and 3x plus 4? That becomes 6x squared plus 4 times 2 is 8x minus 5 times 3 is 15x minus 20. Ooh, that works. Right? So this one can be factored. So you can sit here and do this and you will get your zeros, right? I could set each one of these equal to 0 to solve for what x could be. This would be minus 4 over 2, and that one would be 5 over 3, right? But I could also say I couldn't figure that out. I could use the quadratic. So let me just show you that. Negative b, so negative 7, plus or minus the square root of b squared, that's 49, minus 4 times a times c, all over 2 times a. So x equals 7 plus or minus 49, and all that comes out to, of course I didn't do it, 4 times 6 is 24, and 24 times 20, 480. Is that right? Let me see. 4 times 6 times 20, 480, and then it's positive 480, right? All over 12. And then plus 49 becomes 529. Okay, so those are my two answers, right? Now let's check this. So here, if I had solved this, I would have gotten x equals negative 4 over 2 and x equals 5 over 3 plus 5, yep, which means this is x equals minus 2. So let's see what we have there. First is, does that work out? Is that a perfect square? Oh, that is 23. I didn't know that one. Okay, so let's see. 7 plus 23 divided by 12 is Whoops, that's not right. I need order of operations. 7 plus 23 divided by 12 is 2.5. And then 7 minus 23 divided by 12 is negative 1.33 repeating. So those are my two values. So does that match what we have here? Well, no. So what did we do wrong? Now I'm thinking I did something wrong. Negative 49. You guys find the error. Minus 4. Yep, yep. What about this? Did I do an error here? 2x times 6x squared plus 8x minus 15x minus 20. Yeah, that looks like I did that right. Now I'm going to sit here and find this error. I feel like it's in. Seven plus 23 over 12. Yeah, so 4/3. I think I messed up here. 3x plus 4. Oh, here's when I made a mistake. I figured out this didn't work. Hopefully you guys saw that. And then I used it to solve for x. There's my error, right? What I should have used these two to solve for x. So you guys are probably screaming at me the entire time. I realized it didn't work and then I used them to solve for x. So here is, I should have set that equal to 0. And then 3x plus 4 equal to 0. So 2x equals 5, x equals 5 over 2. Here, 3x equals minus 4, so x equals minus 4 over 3, which now that matches, right? So there. That makes more sense. It's like you're really in the classroom with me. I make so many mistakes when I write on the board. So here we go. So you can use the quadratic to figure that out, or you can factor to figure that out. Okay? This always works. And this does too, but sometimes you have to play around with it more and think about what's the puzzle that gets me to two factors. Last one. The discriminant of a quadratic equation determines the nature of the root. So remember the discriminant, I kind of mentioned it in the beginning, is the thing under the square root, b squared minus 4ac. So you'll start to notice some patterns, is that when your discriminant is greater than 0, you have two real roots. So like in our last example, our discriminant came out to have a value of 23. It was positive. So we had two real roots, two real numbers. Okay? If your discriminant equals 0, there's just one root. And if your discriminant is less than 0, so it's negative, which happened here, right? The value of our discriminant ended up being negative 27. Then because there's a negative under the square root, you know I is going to be involved, so there's two non-real roots. So those are just some general rules to help you figure out how many roots you should have based on the value of the discriminant. Okay, that's chapter 2. It's a wrap. Now it's time for review. See you guys later.